Hello, and welcome to the tutorial on the Recursive Dynamics RGB LED Panel Builder. In this video we'll be going over some of the newest features of the panel builder, and we'll be looking at some ways to save you time and energy when creating your animation. The first thing that you'll notice when you're on the designer page is that this first frame is preloaded. We did this to show a basic outline of what you could do with the pixels on the array. Down here you can see your drawing color, which is the color that the LEDs will light up in when you click them or you click and hold and drag across them. Now you can select a total of 7 different colors, and if you draw on a color that's already been drawn, the pixel will become that color. If you select it again, it will turn off. The duration is the number of milliseconds that this frame will stay active before your animation moves to the next frame. You can change this number anywhere between 1 millisecond and 60,000 milliseconds, which is the same as 60 seconds. To insert a prefab animation, simply select the animation you wish to insert and then click Insert Prefab Animation. Because we've started with the Protogen sample here, I'll go ahead and use the Protogen example. When you click this button, you'll notice that all the other buttons are locked, so you can't click them until this addition is finished. We did this to prevent multiple inserts from occurring at the same time. On mobile devices, it can take some time for this process to finish because mobile devices have less memory available to them than computers do. I would also overall recommend that you always use a PC or a laptop to configure your animation and submit it. So, once we have our animation the way we like, we can go through and look at our frames one by one, and if there's a frame that we don't like or don't need, we can remove it. We can remove all frames except the first frame. Once we've verified that our frames are the way we'd like them, we can scroll down to the bottom and view a simple preview of exactly what our animation will look like on the LED array. We'll also be looking at this same animation on an actual LED array to give you an idea of what it looks like. There's the flicker, and there's the loading symbol, and then the animation is restarted. So a couple more things before submission I'd like to go over are the frame's amperages and the space used. The amperage of each frame is calculated and must be taken into account when you select a power supply for your LED array. If a frame of your animation has all the pixels in the array lit up in the color white, that will draw a significant amount of amperage, somewhere around 16 amps, I believe. Your power supply, at least momentarily, needs to be able to supply this much amperage, otherwise a power supply or power cable failure could occur. As you can see in this example, we have not really exceeded 2.22 amps for any individual frame. So a regular USB charger or fast charger would work for this device. Battery supplies are available and can be used. You just need to make sure that the amperage they can supply is always greater than the amperage of your most amperage dependent frame. The space used is not typically an issue with our new memory expansion on the boards, but if you're curious what this means, it's essentially a measure of how many more frames and pixels you could have in a scene. So you'll notice now that the space used is 5481, and if I go up here and I add a pixel to the last frame, you'll notice now that the total space used is 5485. That's because each pixel that's lit and also each panel that's added to the list of animation frames takes up a certain amount of memory, and you can technically run out of memory. However, it is unlikely. Now, once we have our design the way we'd like it, We click Submit, and in return, we receive a code. This is our customization code. We use this upon checkout to make sure that Recursive Dynamics fills the correct order. Now let's go look at what we designed.